every one of those options needs to be looked at according to the economics. But is it value accretive? Does it add value to the project? Does it reduce the overall costs of the project? So, don't tell me you can't solve how to get water from the air when they put a man on the moon. Like just don't tell me you can't solve that. And of course you can. The number one priority is to say, well, we need a bigger subsidy from government, and that's to us that's subsidy mining. That's not how you achieve this objective. Well, we one thing we can guarantee is we'll keep trying. That's certainly we'll get as close as we can to the outcome. So
My today's guest spent 35 years as an investment banker and a strategic advisor in the very energy and infrastructure sectors that have been, let's say, enthusiastic participants in our current climate adventure. He's a deal arranger, a numbers guy, the kind of person who advises governments on policy and finance. He is, by every definition, the man from the inside. His plan is to go to the Australian desert, where there is famously no water, and build two of the largest energy projects on Earth that will, and I'm not making this up, suck water out of thin air to create limitless clean fuel. He's assembled a team of corporate Avengers like GE Vernova and Yinko Solar to do it on a timeline that makes a Marvel movie plot look realistic. It's a plan so completely bunkers, it might actually be genius. Please welcome the Climate Impact Corporation co founder, David Green. David, for the second time, welcome.
thank you, Arnes. It's wonderful to be talking to you again.
Tell me, what changed since the last year?
Well, a lot of progress. When we spoke last year, we were in Rotterdam, and this year we were far too busy for me to come to Rotterdam. One of the critical aspects for us has been the design of the basis of a project that we believed could meet the requirements for sustainable hydrogen industry and do that at a scale, but address many of those typical large infrastructure risks. And those risks include uh, the enormous amounts of sunk capital that need to go into a large project before you can operate and before you can generate cash flow. And particularly in the sector we're in, which is a nascent sector, is the potential for regulatory change and also technology change. So those things need to be thought of very carefully as you plan and design a project. And for us, we went back to a clean sheet of paper. We were lucky as a group, a company. We don't have existing assets that we need to protect. We're not one of the big oil and gas players that are in transition, or one of the big mining groups, or or, or those that are having to pursue a decarbonisation strategy as well as introduce themselves into a new market. So we were able to go back to look at all the fundamentals of what was required to produce hydrogen on a competitive and sustainable basis, and we built our whole strategy around implementing that. And when you and I spoke last time, we had just announced, even though we'd been working with GE Vernova for a little while before that, we'd just announced publicly that we had developed a joint development arrangement. And I might come back to that because it's a really important part of our overall strategy. And but one of the things that we have done in the last 12 months is progress that design of the basis of our projects, the very large scale projects. As you said, those two large projects in Australia are 10 gigawatt each.
Yeah.
So very large projects. But they're based on a modular concept and a modular design, which is totally off grid and recognizes a number of things, which I think we can go on to talk about. But since we met and talked, we've now taken that design and we're implementing that into the early stages of those projects, and that's been an enormous amount of work and enormous amount of progress in that time.
So, David, you're planning two 10 gigawatt hydrogen projects on a timeline many would call impossible.
Mm.
What's the brutal reality of that schedule today?
We probably slipped about 6 months, but in terms of the schedule, but that timing has really come about because, well, that change in timing has come about predominantly because we were focused on working with the OEMs, and this is another important part of our strategy, is we recognized very early on that in a new industry, much of it, particularly if electrolyzers are a good example here, uh, the way in which that equipment had been designed for the market in which it was operating was not um, necessarily generating the type of technology that would suit the market demands that we're going into for green hydrogen. And that meant the first thing we needed to do was to effectively scan all of the OEMs to identify those that had a number of characteristics. One was they could identify the market was changing and they needed to adapt, and they had a willingness to adapt.
Yeah.
Some in the industry, not just the electrolyzer industry, but other industries that impact on the production cost of green hydrogen, are not adapting, and others are taking the view that, well, this is the way we do it, and this is the way we're always going to do it. So we decided that what was really critical was for us to identify those OEMs that had met the criteria that we thought was critical, and that we started working with them on what we required from their equipment. And so that's with electrolyzers, for example. As you know, there's a
Yeah.
choice of technologies, but what we needed was a technology that could be bankable, could be mass produced to get the unit scale cost down, but also that the existing technology improved, not a new technology introduced. That's important as well. But for the current requirement, we chose the, yeah, probably the best, certainly at this stage, the best option would be to work with an alkaline electrolyzer, or a number of them, manufacturers that had the ability to then produce second generation alkaline electrolyzers, which meet a number of criteria that we have. And that is, for going off grid, we want to keep the capital costs as low as possible. So
Yeah.
we don't want any dead weight capital, no dead weight capital to be included, which means if we need batteries, um, we want to have the least cost we can in that regard, and so the smallest battery that we can have. So to do that, you have to overcome some of the fundamentals of renewable energy, and that is its intermittency.
Yeah.
And so that was another challenge we took on with the OEMs and said, if you want to truly operate in a green with green energy, and let's face facts here, most of the world their grids aren't green,
Yeah.
and they won't be green, fully green for a long time. So if you want fully green um, and yeah, totally renewable hydrogen produced, you've got to be off grid or on a grid that's totally green. And so that means you either have big batteries.
Yeah.
You can get some benefits in some locations from a combination of wind and solar, but every one of those options needs to be looked at according to the economics. So if you look at one factor in isolation, like do you get a better energy profile by combining wind and solar? The answer to that might be yes. But is it value accretive? Does it add value to the project? Does it reduce the overall costs of the project so you're able to sell the output at a cheaper level? And so every aspect we look at like that. So the so that then leads you to have to solve a number of really critical issues if you want to go off grid and operate in an isolated area to capture the best solar irradiation. And by its very nature, the best solar radiation is often where um, the climate's the toughest.
Yeah.
It's difficult to make land productive, and so infrastructure is often not there. Typically, you don't have the transmission networks simply because there's not a lot of productivity to be had in that area. And
Yeah.
so then we had to move on to how do we solve the water issue in very, very dry climates. And Australia is a very acute example of what happens in a very, very dry climate. So we decided that we could have a very aggressive target for our projects, but what we were better to do is to set aside some time to really address those fundamental issues and ensure that we had secure supply chains with the OEMs that were going to be critical to us being able to deploy our modularized system quickly once we finalise what we were comfortable with design. So that's what's sort of delayed the project schedule by about 6 months. But overall, I suspect the it's accelerated the project delivery component of that.
And mentioning GE Vernova and Jinko Solar, how do you manage, the massive integration risk to stop it from falling apart?
Mm. Yeah, well, that's a very very good question. We have so what we've done is surround ourselves with people who have a common interest in finding solutions to problems. And one of the things we're very happy about with the parties that have come to us, like Jinko and working with us, GE Vernova, one of the very early parties was the approach that they took to this this industry, this nascent industry, and that is that there were nothing but problems or issues to solve, and and there was no point in going into it unless you had a belief that, as I've often said to people, yeah, don't tell me you can't solve how to get water from the air when they put a man on the moon. Like just don't tell me you can't solve that. And of course you can. It's whether you can make it work economically ultimately. And one of the things that was really pleasing with GE Vernova was the way in which they they like us took the view that this was an enormous challenge, and but with the right people, um, and a willingness to really take on the challenge, then we were going to get a long way there. And so what we have tried to do is to build. I don't like this term because it has connotations of its previous use, but a coalition of the willing of parties that say yes, we really appreciate how challenging this is, but we can see that the strategy has real merit, and we are taking a different approach to most others, we're told. And that's one of the things that's attracted people because, as GE Vernova said to us, I probably shouldn't put words in their mouth, but so many people have said this to us. In fact, many large players like GE Vernova is that they look at literally every hydrogen project in the world, and
Yeah.
so many people are just pursuing the same strategy
Yeah.
to doing a project, and um, and you're not going to. If sorry, I shouldn't say you're not, but it's going to be extremely difficult to just take the same approach to doing large projects that you may apply in infrastructure or oil and gas industry and assume it will work in this situation. And so we've had people crawl all over our strategy, crawl through our data room, and the thing that they all attracted to is the innovation, the approach that we're taking, the overall strategy, and the willingness to just keep driving towards achieving that. Really importantly, from our perspective, is focusing on reducing the cost of production.
Mm.
And often you find very rarely that proponents, industry, sorry, proponents and projects in this industry uh, talk about our number one priority is to get the cost of production down. It often seems as the number one priority is to say, well, we need a bigger subsidy from government, and that's to us that's subsidy mining. That's not how you achieve this objective.
Yeah,
So
for
we've
sure.
we've been very lucky to have those very large corporations with incredible capabilities. Um, some of the things that we're doing with GE Vernova that we can't talk about now, but we'll see really material costs cuts in the cost of electricity. And as you know, electricity accounts for 70–80% of the cost of production. And we're talking
Mhm.
really material cost reductions there that we'll be able to introduce because of them. And their role, which is really important in this process, is to squeeze every bit of it, of electrical efficiency out of the way in which we integrate the project, but also the various operating modes because we're off grid.
Talking about the price, pulling water from desert sounds like magic. What's the
Mm.
hidden energy cost of that magic? And does it threaten the module's efficiency?
And look, I'll just be careful about what I say here because it's one of the things that we haven't wanted to talk too much about. So we there's we've applied for a whole series of patents and so on. But what I can say is that technology is been around for so much longer than people appreciate. And the first thing, I have a long history in water industry as well, and was appointed by the Australian government to a number of really critical roles to help with some of the most drastic um, drought conditions we've had in Australia and infrastructure around that. So I have a very acute understanding both of the issues in the impact on climate in those sort of conditions, not just in Australia but elsewhere, and also the technology. for water efficiency technology. I'm involved in doing 2 desalination plants in Australia, so I'm very familiar with that technology and its costs, and also its limitations. And while I'll use Australia as an example, it's equally applicable to pretty much anywhere really, and that is and this is I'll just diverge for quite just a second. The EU put out a report just recently, and they quoted that by 2030, the world will be short by 40% of the water it needs. What they mean by there, of course, is for human existence, not that we'll run out of water in the oceans.
Yeah.
Um, and that was an issue once again that we identified right at the beginning, because when we looked at when I was appointed as a water commissioner in Australia by government, we looked at the opportunities for locating a desalination plant on a Queensland coastline, and that's 9,500 kilometre coastline. We engaged one of the international consultants to do that work. In the end, they could only identify 3 sites that would be suitable because of um, all of the other opportunities being impacted on by either environmental factors, regulatory factors, or cost. And you can apply that pretty much anywhere in the world, and you'll get very similar sort of outcomes. It'll vary depending on how much government wants to override the regulatory and the environmental. So desal has uses, but it also has it can't be used in every instance. It's the best way to look at it. So I don't want to be critical, because it is an important tool in addressing water shortage. Um, but surprisingly, a very large amount of the world is water stressed already, and by 2030, major water stress. So
Yeah.
if you're going to develop a large scale industry to provide hydrogen, green hydrogen, then you need a lot of water.
Yeah.
And there's been some really naive studies done that estimate the amount of water and say, oh, well, the world has this amount of water, so we're only going to take a small amount. There's no problem. The thing that people miss in all of this is that the climate is changing. So rainfall will fall in different places to where it has in the past. It'll fall at different intensities, and it'll fall over different time frames. So history is not relevant to the future in that regard. And so when you say, well, where can we get water? And remember, humans have generally aggregated around water because they need it. So cities have grown up around rivers and the coastline and so on and so on. So the further you have to move water, so you can apply the rule of threes in water. So one megawatt of power is needed to move 1 kilogram of so 1,000 liters of water, which is one metric ton, 1 kilometer. So
Mm.
it's very energy intensive to move around. It's very heavy. So you need it produced where you want to use it.
Yeah.
Otherwise, it's very costly. With desalination, you've got the environmental issues to deal with, and you have to locate desal near the coast. So if you look at a lot of projects, and some of those in Australia that have fallen over, the natural presumption for the people who were conceived those projects was to say, well, let's locate near the ocean because we can put desal and we can connect to the grid. Well, grid costs in Australia are 20 to 25% higher than off grid.
Mm.
And with on grid, you're paying, you can't get energy price stability over the life of the project. So it's the major risk. Then with a desal plant, you're investing $300-400 million before you produce 1 litre of water, and you can't produce 1 kilo of hydrogen before you get your water.
Yeah.
And so a number of projects have fallen over because they can't get water either.
Yeah.
And I can talk about some of the other reasons, but so we had to identify how do we solve that problem. We were aware of this technology, so we spent more than 2 years working with pretty much every atmospheric water generation company that exists.
Mm.
Some of those companies are offshoots from air conditioned companies, which is more or less the same technology, but slightly different. But with air conditioning technology, what you're doing is conditioning the air by taking the humidity out, and that water is the waste
Yeah.
in that instance. And many industries, like the lithium battery industry, is has to have dry air. And so that sort of technology is used extensively there to dry the air. So, and many other, Coca-Cola uses it, uh, Samsung, there's a whole heap of majors. So that, but in the atmospheric water generation application, that technology's been used since about 1960. So that's when it was really industrialized, since 1960. And so
So talking about these complexities, and the complexity of making derivatives like ammonia on site, isn't that adding a huge risk to an already audacious plan?
um, in what way do you think? An extra
In
process, you mean? Or
Yeah, yeah,
yeah, look, we don't think so. I think certainly the way so we know we can pipe hydrogen, but there's, as you know, there's issues in piping hydrogen or storing hydrogen, and those are still being overcome. Even though uh, we can, there are a number of pipelines in Australia that we can connect to that would take, um, an LNG pipeline would take liquid hydrogen, for example, up 20 or 30%. Um, but in terms of ammonia, really what we're doing is looking at a process and technology that has similar sort of characteristics to what we do in the hydrogen production. That overcomes one of those technical issues that is a consideration, and that is how do you minimize storage costs if you've
yeah.
got an intermittent production of hydrogen with technology that prefers to run like a base load 24/7. And that's something we focused on very heavily as well. So we're working with Topso and a Japanese group who both have technologies that are able to accommodate that intermittency. And so they can flex up and down in terms of their production. So that allows us to so the process, as you know, for producing hydrogen is not complex. The issues for us were to deal with the way in which we could minimise the storage and and transport costs. So we're locating the ammonia production facility next to the hydrogen production. We can use the pipelines, interestingly, to pack
Mm.
some of the hydrogen, so that we've got flex there, and then the transport is our projects are located on National Freight Rail, so um, we have an option in the future to put hydrogen directly into mix with the LNG gas pipelines, and there's also hydrogen dedicated pipelines being developed in Australia, which we can tap into at a later point. But our initial assessment is that we'll transport by rail, both
Mm.
to from where we are down to Adelaide, and in the north for the northern project up to Darwin.
A year ago, you called government help a regulatory risk. Now you're asking the Australian government to lean in. What changed?
Oh, when we talk about government support, what we mean is not monetary support. That's where I
Yeah.
see when I refer to government support in that regard, the regulatory
Yeah.
risk is government. Um, the government can change, policy changes. We can have, and Australia's had a track record of this over the last 10, 12 years where our different sides of politics have had distinctly different views. So if you try to bank a project on the basis that you have certainty in terms of government subsidy, that is what we would consider a significant regulatory risk. Where I
Mm.
think governments can play a significant role in supporting a nascent industry like this is those facilitating policies that direct the supporting infrastructure to be in place. So, for example, with a port, and this is happening in Australia with our export ports, is to ensure that they have um, the right sort of regulatory framework put in place to allow them to facilitate handling of those products through the port. You yeah, if governments don't remove those sort of barriers,
Mm.
that no matter how much funding you have, you're
Yeah.
not going to get through. So those things are critically important, as are things like being and having storage capacity able to be provided at ports and potentially cracking. So with what we're looking to do to export to Europe, we built our full supply chain from equipment manufacture through to supply now. So we're able to talk about that. Um, and so we're looking to supply into Europe, ammonia into Europe. We're part of the VTTI process, that open market process to get access to storage and cracking facilities. So we'll be able to as well as sell our product to people who have facilities, storage and cracking. We'll be able to provide to off takers in Europe who just want to have the product delivered
Yeah.
into the hydrogen backbone, for example.
So talking about governments and the state of hydrogen around the world, I'm very curious. What's your take on this state? Say China, US, Europe, and starting with Australia, knowing that a lot of projects were canceled, stopped, or delayed.
Look, I think the industry's about where we expected it to be honest. I think
Yeah.
as often is the case, the hype can be too much one way or too much the other way.
Yeah.
And you had to go into this industry, you had to be really pragmatic about the challenge you were taking on and the time frame it was going to take to address these things. And we've always talked about achieving the US $2 per kilogram production price for hydrogen by 2030. We're not saying we can do that today. We've made enormous progress, better
Mm.
progress than we thought we would, frankly, to that. But it's with these very large projects, you have long lead times, lots of issues to deal with in a large project in any event, which can impact
Mm.
on timing, um, all sorts of factors. And then when you add to that new challenges to overcome, like integrating technology that's never been designed to operate intermittently with an intermittent energy source and minimizing costs, it in our view, it was always going to take that time. We always anticipated that it would. We started on our strategy nearly 4 years ago, more than 4 years ago, in fact, and we've been implementing that. And our expectation was it'd be around sometime this in 2025 where we got to a point where we'd be in a position to say with confidence to off takers, yes, we can achieve and we're prepared to contract with you at $2 per kilo. And I think the thing that um, I've seen, and this happens, it's the market, isn't it? Really, it's some people get over enthusiastic, some people are very um, cautious, and then those over enthusiastic and not well prepared often fall away, and then you get the pessimists say it's all going to be a failure, and then you get those who have to continue, succeeding. And the thing that people often say to us is, well, always hearing projects fall over, always hearing there's no future in this industry. But you only have to look at some of the facts to know those things are not true.
Yeah.
Um, what is the demand for hydrogen coming out of Europe? Well, it's substantial, very substantial. And the instruments being put in place to support that are progressively taking hold. We're getting more clear signals around our price on carbon, whether that's introduced into the carbon tax or whether it comes through a market mechanism. That's extremely important. We're getting government instruments like a contract for difference in Japan, which tries to drive towards, once again, a cost reduction strategy more than a subsidy strategy. We've got the big users of natural gas in Japan. They've already committed, and this is supported but through legislation they have to comply with. They've committed to reduce the use of of LNG to 5% by 2050. If you look at the volumes they purchase, and they've already made the decision what product they're going to use. They made the decision a couple of years ago, but we still get, and it's all public, like there's no secret here, but we still get asked by people who should know better, um, oh, but do you know what product you're going to supply? We're going to supply the product they want. They have to, they have to have. It's not complicated. They said this is the product we want. So that's what you've got to supply, and the volumes are huge. Now there may be some timing delays here and there. But if you don't factor in timing delays in big projects, then you're incredibly naive.
Yeah. And you're competing against state-backed giants. What is your actual sustainable advantage over them? You have offtake interest to support these huge projects. And how many of those are truly binding contracts that a bank would finance?
Well, we've just had come on board with us, and they prefer we don't use their name just yet until they're comfortable. But one of the world's, it's probably the world's leading project finance bank. They
Mm.
put us absolutely through the gorilla on. They did very thorough due diligence on the projects and us, and in fact went to the investment committee as part of that process. So they're on board with us. But coming back to the first point you raised, how do we compete with those big government backed utilities? Well, one of those fell over in Australia. And one of the things that we have that others, and this is the case where some of these projects are backed by multi-billionaires as well, is, you know, we're it's a relatively small team.
Yeah.
We're supported by people like Wally, like GE Vernova, like Jinko, who understand the strategy and know that this is all about getting the cost down. It's not about producing hydrogen. You don't need to do a study. You don't need to do a pilot to demonstrate you can produce hydrogen. What you have to do is to produce hydrogen at the price that is competitive. And we had a big project in Australia that was supported by the Australian government, Japanese government, possibly Korean, I can't recall now. Um, and a lot of money was spent on that, and it was cancelled a little while ago. It was what I think of as the Stanwell project, but it may have had I think it had a specific name, but that was one of the big projects in Australia that got Queensland government support, Australian government support, Japanese utility support, and it was never going to be successful. It could never have been successful, and one reason was they didn't have enough water.
Yeah.
I helped develop the water strategy for Queensland. I know they didn't have enough water. They should never have started. So coming back to the point of that is we're nimble.
Yeah.
And we also, the three founders of this company invested all their own money before we asked for anyone else to support
Yeah.
us. So we had to be absolutely certain about what we were doing and confident that we could make it a success. Now, when you're a huge organization, another one that pulled out recently was Origin in Australia, one of the big energy companies. Now, the question I have is how could so many energy companies who should know better spend so much money trying to do the same thing that they've done in the past and expect it to work?
So there are
And
two things that you reminded me of, and one is that the definition of insanity is to actually do the same thing and expect different result, and the other one is I've read the book from Ben Flyberg. I truly recommend that to everyone. How big projects fail,
mm,
and it's just amazing how this happens and how many projects are purely based on hope. The other day, I spoke with the guy from DOE that has actually supported through his role many projects and companies in US, and he says, you know, people are just coming to us with dreams. They don't have the real analysis. They don't have the real data, and then you just spill the money, and there's a high risk of these government supported projects because they are actually supporting that everything that banks wouldn't, you know, and
mm,
it's like huge percentage of that is actually just being wasted. Like a very small percentage is successful.
mm. Yeah, I look, I totally agree. And the other question I have is how many government institutions are in a position to evaluate what's worth supporting in a new industry?
Yeah,
New technology has to be developed, but it is being developed, and that technology will change the dynamics over the next 5 years. Regulatory policy is still firming up. We're now seeing, as I'm sure you're seeing, in different parts of the world, governments have introduced their hydrogen roadmap. They're now realizing they've got to come back and adjust that policy, um,
yeah,
as they always would. But um, some of that original understanding of where the market would go was misguided, mostly because the information was very difficult to assess at that time. And so this we're not talking about producing mobile phones here, where there's a long a long path you can copy. We're talking about a very large industry that has got a lot of dynamic change occurring constantly, and that's why as a firm that's nimble, we can adjust to that. But we also you know you have to question. I would question the motivations of some of the companies who pursued these large projects, because if you're a company that's looking at having to decarbonize or um, to defend the value of the existing assets, what is really driving the investment
yeah,
decision there? Is it Is it to produce a product that is competitive with a carbon-based fuel, or is it driven by another strategy? Similarly, with governments, in
Mm.
Australia, we have enormous royalties earned by governments for the sale of LNG and coal. And so, yeah, is an investment by a government in the project like the Stanmore project really about protecting the value of an asset, or protecting substituting a revenue stream, or what is it? Is it and so I think when you look at a number of these projects that people have mothballed or cancelled altogether, one of the things I think is, well, what was their motivation for going into it
Yeah.
in the first place? And if it wasn't to go into it with an expectation that to be sustainable, you had to do that on a purely commercial basis.
Yeah.
And that meant you had to compete on price. Competing on price, though, where there's also a price for your competitor on any emissions. And so that's where, things are also still starting to solidify themselves in this nascent industry, and that is that we can we are really confident. We are really confident to the point that we're in negotiations now, advanced negotiations with term sheets contract at $2,
Mm.
right?
Wow.
For 20 years take or pay contracts. And we're extremely confident about that. But the places we're confident in doing that is where we know there is a a price, a, a mechanism that puts a price to emissions,
And
and
yeah, you
and
are,
the, and the, sorry, and that then there's certainty around that price. It's not something that is just blue sky.
yeah,
It's got to be certain.
yeah, clear. And you're aiming for net zero shipping also. What
Mm.
cost does that add? And are your customers actually willing to pay for it?
Well, we see that we see what we're offering, and we can bundle. This is the way we look at pricing the product. So we can we everything for us is about driving to the price that makes sense for the customer, who has to move to a renewable fuel as a substitute for their current fuels. So let's just use LNG as the
Mm.
example. And that's challenging, as there's no doubt about that. But where you include the price of carbon, and that's a legitimate market, not an artificial market where you can't observe price or anything like that. It has to be a market. What we do is we say to the customer, well, yeah, what carbon intensity do you need in your product? So as you probably know, in Japan, they set a different benchmark to Europe.
Yeah.
We can give that, we can effectively, our supply chain, you could, it would be hard to see how you could get a lower carbon intensity out of the supply chain. So in terms of our production, we are totally off grid. Everything through our supply chain, we look to have, where possible, produced through renewable energy. So all the way through, and we control our supply chain from the manufacturer of equipment all the way through. So in terms of shipping, for example, we have a company that we work with that has started implementing its strategy a number of years ago. So they only use renewable fuels, and they only transport um, products that are renewably based, or they've been working to that. And so, in terms of their carbon intensity, the biggest issue they then have to resolve is if they're refueling at a port, where do they get the fuel that they need. And as you know, the shipping industry's just introduced that obligation. So, but in terms of the carbon intensity of our shipping, it's as low as you can get. Same with the manufacture of the equipment, and of course, we produce in terms of the production of our hydrogen. We over the life of the projects will produce about 500 million tons of carbon offsets.
Right.
So that's an enormous amount of carbon offsets to apply where we need. So if a customer says to us, well, look, actually, if you trade those carbon offsets in the Australian market, it's worth X dollars, but
Yeah.
we can actually get a higher value for them in our market. So we'll say, okay, if that's we're happy to strike the price with you, where you pay a particular product a price for the hydrogen, uh, and we give you the credits. You then net that off against the price we charge you for the hydrogen. Or the other option is we apply the monetization of the credits to reducing the price of the product to the customer. So everything's
And
structured to get the maximum benefit to reducing the price to the customer.
yeah. And my final question. Now imagine it's 2030 and you've succeeded. Paint me a picture. What does that look like?
Um, well, we're already so part of our strategy right from the beginning was to design. Um, we always had the concept of a module as the basis of very large projects because it drives multiple risk mitigations, but also multiple benefits in terms of pricing, which I'm happy to go into. But the one part of that strategy was to design a standardized module which could accommodate new technologies. So, for example, if a if we decided we wanted to switch to AIM electrolyzers because they'd now developed commercially and were bankable, we could swap those in. Um, so we have that flexibility in our design. But overall, the modules are standardized, so and the intent is to be able to deploy them rapidly. So we've already started um, in well, we haven't announced it, so I suppose we're announcing it publicly through you, but
Yes.
you've got a scoop here. But we've already sort of started to progress in the UK, sorry, US, on the East Coast project, and looking to do initially a pilot there just to demonstrate to the local market the scale. But we've identified the land and we're in discussions with gas pipeline owners about connecting for a large project and then doing the same in Oman and the UAE.
Mm.
And one of the things we're finding as we talk to some of the bigger groups that are around that that have been trying to progress projects in some of these areas is once again they're struggling with how to get um, they've got they've won an auction in a hydrogen hub or something like that. They've invested $50 million so far, but everything they're doing is pointing to them not being able to get to $2. So now they're saying, well, how else can we approach this? And so we're finding more and more people, as well as us. There's so many areas around the world where our module suits. Like we we're doing in our two projects in Australia, we're doing 4,000. Another one that the counterpart doesn't want us to make public yet that we're doing is a single module co-located. This is a really interesting one, co-located with a gas-fired power station.
Mhm.
And so the module will be built on the power station's boundary, and then it will provide hydrogen for mixing with their LNG to fire their gas-fired power station. And that overcomes a lot of the impediment for decarbonising gas-fired power stations, because a lot of the problems they've had so far is getting the hydrogen to them.
Yeah.
It has to be produced, of course, then it has to be shipped. Well, we've actually moved the module to where they want to burn it, and so that's another one we'll announce soon. But in 2030, I would hope to be sitting talking to you and saying we've done, many gigawatts in the US, many gigawatts in the Middle East, in Northern Africa. We're in discussions with European counterparts for projects in those regions, or the output of those regions. And so it's the modular nature of what we're doing and its ability to operate independently
Yeah.
of associated infrastructure that has so much capacity.
David, thank you so much for being my guest today.
Oh, it's a pleasure, and hopefully not so long till the next time we speak.
For sure, we are following your progress, and it's very, very interesting. And you're a great example of how this can be done in a right way.
Well, one thing we can guarantee is we'll keep trying. That's certainly, we'll get as close as we can to the outcome. So
Thank you.
nice to talk to you again.